There's a gun in your hand that's pointing at your head. You think
Alright, today we'll finish off section 2.2, which is on greatest common factors and least common multiples. We talked last time about what a factor is. Remember that a factor is a number that you can numbers that you can multiply together to get another number. So for example, the factors of 10 are 1 and 10, because 1 times 10 equals 10, but also 2 times 5. 2 and 5 are also factors of 10, because 2 times 5 equals 10. So when we're looking for a greatest common factor, that's when we're talking about more than one number at the same time, and what we're looking for is the largest number that divides each of the given numbers exactly. For example, if we wanted to find the greatest common factor of 18 and 12, well, let's just think of this for a second. The factors of 18, what are the factors of 18? Well, 1 is a factor of 18 because 1 times 18. 2 is a factor of 18 because 2 times 9. 3 is a factor of 18 because 3 times 6. Those are the factors of 18. What are the factors of 12? By the way, do you see how I did that? How I kept space and everything? I want to show you a different way you can do this. The factors of 12 are 1, because 1 goes into 12 evenly. 2 goes into 12 evenly. 3 goes into 12 evenly. Now 4 goes into it as well. And you see how you have this pair here, 3 times 4? You know once you get that, you've got this pair, that you've now, all you have to do is find, well, what multiplies 2 to get 12? I need to multiply 2 times 6. And what do I need to multiply 1 by to get 12? I need to multiply it by 12. So that's another way you can figure out all the factors. Anyway, what are the factors that are in common? Well, they both have 1, they both have 2, they both have 3, they both have 6. That's it. All these highlighted ones are the common factors, but we're looking for the greatest common factor, which means we're looking for the biggest one. The greatest common factor is 6. That's the biggest one they have in common. Now, that's great when you have numbers like 18 and 12, but what if you had numbers like 138 and 198? You don't want to do it this way. This would be way too hard. So we need a different method, and here's the steps for this other method. First thing you're going to do is you're going to find the prime factorization of each number. Hey, we did that last time. Remember that was those trees, those tree factors. So we're going to do one of those for each one of the numbers. Then we're going to list each common factor the least number of times it appears in any one number. People hate this. Why do they hate this? Because this is the greatest common factor, and yet you take the least number of times it appears. I know it's weird, but that's the way it goes. I'll explain that in a second here, and the last thing you're going to do is you're going to find the product of the factors. Okay, so let's work through one. Find the greatest common factor of 138 and 198. The first thing we need to do is find the prime factorization of each number. So I showed you two methods to this last time, and I told you the method I liked was the tree method, so that's what I'll do. 138. What multiplies to get 138? I don't know. 138? Who knows? I know it's even, so I guess 2 goes into it. How many times? 2 goes into 13 6 times with 1 left over. 2 into 18 goes 9. 2 goes into 138 69 times, which I'm sure delights some of you. Okay, what can we multiply to get 69? Well, I know 3 goes into that. 3 goes into it 23 times. And what goes into 23? Nothing. It's prime. In fact, all of these are prime. The 2, the 3, and the 23. Those are our prime factors. So the prime factorization of 138 is 2 times 3 times 23. Let's do the same thing for 198. Again, I don't know what goes into 198, but I see it's even, so 2 must go into it. 2 goes in 99 times. 99, what goes into that? Well, we could do 9 and 11. I know that works. Are those both prime? No, 9 can break down into 3 and 3. So our prime factorization is 2 times 3, but I'll put 3 squared, times 11. Okay, we've done the first step. The second step, list each common factor the least number of times it appears in any one number. So for example, in this first number, 138, there's the factor 2. Does that factor show up in the second one? Yes. How many times does it show up in the first one? Just once, right? It's just 2. It's not 2 squared or 2 cubed. How many times in the second one? Just once. So the smallest number out of 1 and 1, the smallest number is 1. So we put 1, 2. Okay, the next factor we have is 3, and there's only one of them, and 2, 3 squared, and there's 2 of them, so 2 3's here. What's smaller, 3 to the first power or 3 to the second power? 3 to the first power, so we just take that 1 3. Now we have 23. We have 23 here, so 23 to the first. We have 23 here to the 0. Like we don't have a 23. So what's smaller, 1 or 0? 0, so we don't put the 23. And what's the only other number we have? 11. We have one of them here, but we have 0 11s there, so this is it. So 2 times 3 is it. The greatest common factor of 138 and 198 is 6. Should we do one more of those so you get a clear idea? 150 we start with, and we need to do the prime factorization. Well, we could do 15 times 10, and then break 15 down to 3 and 5, and 10 down to 2 and 5. So our prime factorization is 2 times 3 times 5 squared. 275. 25 goes into that. 25 into 27 is once, with 25 there is once. 11. That's prime, the 11, but 25 can be 5 times 5. So you get 5 squared times 11. 420, which also might delight some of you. That's 42 times 10. 42 is the same as 6 times 7. Remember, you can do all sorts of different ways you want here, but this is the way I'm doing it. 2 times 3, that's prime, and 2 times 5. So you get 2 squared times 3 times 5 times 7. Now, what do we have? Look at the factors. We got 2. We have one of them here, 2 of them here, but 0 of them there, so we don't put 2 down. 3, we got one of them there, but 0 of them there. Don't put anything down. 5, we got 2 of them here, 2 of them here, but only one of them there. So it has to show up in all of them, and the least amount we have is 1. 11, one of them there, 0 and 0 there, don't write it down. And 7, one of them there, none of them there, none of them there. This is it. The greatest common factor of these three numbers is 5. Okay, so just to make this point one more time, remember that even though it's called the greatest common factor, when we looked at the factors, we took the least amount of each one. We looked at the smallest exponent, and that's what we wrote over here as our factors. Now, the next thing we're going to talk about is multiples, and this is what people often get factors confused with. So what a multiple is the product of a number by a whole number. Kind of a weird definition. When I show you an example right now, you'll get it. The multiples of 9 are 0, 9, 18, 27, 36. You see, all you do is count by that number. Like when you learn to multiply, that's what you did, right? 9, 18, 27, 30. Why are these the multiples? Because 0 is 9 times 0, 9 is 9 times 1, 18 is 9 times 2, 27 is 9 times 3, 9 times 4, 9 times 5. How many multiples are there? Infinite. There's always infinite number of multiples. Remember, with factors, you could have 2 factors. We call it prime. You could even have 1 factor, the number 1, or you could have 4, 6, or 12, or whatever. But for multiples, there's always an infinite number of them. Okay, we did greatest common factors here. Now we're going to do least common multiples over here. What's a least common multiple? It's the smallest common non-zero multiple. Too bad it couldn't just be 0. Then the answer every single time would be 0. What's the lowest common multiple of 12 and 20? 0. What's the lowest common multiple of 96 and 90? 0. Unfortunately, that's not what the answer is. We want it to be the smallest non-zero multiple of 2 or more whole numbers. So the smallest number that's divisible by all these. When you use this all the time, you've done this before, lowest common multiples. We did this with lowest common denominators, right? With fractions. When you're trying to find a common denominator and your teacher says, what's the lowest common denominator? What you're finding is the lowest common multiple. So, lowest common multiple of 12 and 20. Well, multiples of 12 are 0, 12, 24, 36, 48, 60, 72, 84, ... goes on forever. Multiples of 20 are 0, 20, 40, 60, 80, 100, ... goes on forever. The ones that are uncommon are 0, and what else do you see in that's common? 60, and the next one would be 120, but I don't have it there. So those are the common multiples. The lowest one, I know you're saying the lowest is 0, but remember it has to be a non-zero multiple. So the LCM, the lowest common multiple, is 60. Okay, again, that's great for questions like this where it's 12 and 20. What if it was 96 and 90? That's a much more difficult question. So we need some steps to do this faster. And it's very, very similar to what you did with the greatest common factor. Again, you're going to write things in their prime factorization. You're going to look at the primes. But this time you're going to take the greatest number. So again, it's backwards. This one's called the least common multiple, and you're taking the greatest number of times the factor shows up. For the greatest common factor on the other page, we took the least number of times the factor showed up. So it's backwards, it's opposite. And you're going to find the product of the primes. So again, the steps probably are more confusing than just showing you an example. Find the lowest common multiple of 96 and 90. So the first thing I'm going to do is I'm going to do the prime factorization of these two numbers. 96, well, 2 goes into that 48 times. And then 48 is the same as 8 times 6. 8, 4 times 2, and 4, 2 times 2. This 6 here, 2 times 3. Wow, this is confusing. What have I got here? I've got 1 2 here, and another 2 here, and another 2 there, and another 2 there, and another 2 there. So that's 5 2's and a 3. So the prime factorization is 2 to the 5th times 3. Okay, for 90, well, I could do 9 times 10, and 3 times 3, and 2 times 5. So it's 2 times 3 squared times 5. Okay, just like with the greatest common factors, we look at the factors, but this time we take the biggest exponent. So here we have 2, a factor of 2, 5 of them, and here we have a factor of 2, just 1 of them. What's bigger? The 5. So we have 2 to the 5th. This is how we get our lowest common multiple. 2 to the 5th. We're going to multiply that, right? We're going to get the product by, what's the next factor? 3. We have 1 of them here, we have 2 of them here. What's bigger? 2. So 3 squared. 5. We have 1 of them here, we have 0 of them here. What's bigger, 0 or 1? 1. So we have to actually include the 5. Okay, we got to figure out what that equals. 2 to the 5th is 32. 3 squared is 9 times 5. So it's 32 times 45. And if you multiply 32 times 45, you get 1,440. That's the lowest common multiple of 96 and 90. So if you counted by 96, one of the numbers you'd hit is 1440, and if you counted by 90, you'd also hit that number. Okay, when there's 3 or more numbers, you can do the exact same thing I just did here, or there is an alternate method, which I'd never seen before. It's kind of cool. It's the first time I saw it, so there you go, I learned something. This is for when there's 3 or more numbers. You could divide by a prime factor that can divide 2 or more of the numbers, bring down any number that does not factor, and then repeat until no remaining numbers have any prime factors in common. Blah, 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 blah. Let's just do this twice. We'll do it once the way I just did it, and then once this new way. So the first way I'm going to do it is I'm going to do prime factorizations of all these things. I want purple. Here we go. 18, prime factorization. This will be fast. 18 is the same as 6 times 3. 6 is the same as 2 times 3. So we have 2 times 3 squared. 20. 20 is the same as 4 times 5. 4 is 2 times 2, so we have 2 squared times 5. 30. 30 is the same as 6 times 5. 6 is 2 times 3, so we have 2 times 3 times 5. So to get the lowest common multiple, we look at the first factor, which is 2, and we take the biggest exponent. We have 1 here, 2 here, 1 there. What's the biggest? 2, so 2 squared. Let's look at 3. We got 2 here, 0 here, and 1 there. What's biggest? 0, 1, or 2? 2. So it should be 3 squared. Next is 5. 0, 1, and 1. What's the biggest? 1. So you got to do this to get your lowest common multiple. 2 squared is 4. 3 squared is 9 times 5. That's 36 times 5. It's 180. That's your lowest common multiple. Okay, let me show you this new way. So I'm going to write, this is kind of like that box method we did before last day when we were finding factorizations. I'm going to write the numbers in here. I'm going to look for a number, a prime number, so that's really important. It has to be a prime number that goes into at least 2 of these, or all 3 of them, but it could just be 2 of them. So what I see is that one prime number is 3, and that goes into the first number, 18, and also the last number, 30. So let's pick that, 3. Okay, so when I divide all these by 3, 18 by 3 is 6. 20 by 3, it doesn't go in evenly, so you just bring it down. You see how it says bring down any number that does not factor? Just bring it down. It didn't work. I couldn't divide that by 3. 30 by 3 is 10. Okay, now I look at these numbers. Is there something you see here that goes into both of them? Or at least 2 of them, sorry, or all 3 of them? Well, I see that 2 goes into all of them. I could also divide 20 and 10 by 5 if I wanted. Let's do 2 because it goes into all of them. I kind of like that. So 6 by 2 is 3, 20 by 2 is 10, and 10 by 2 is 5. Do you see a prime number that goes into at least 2 of these? Yes, 5 goes into the last 2. So the 3 just comes down because 5 doesn't go into 3. 10 divided by 5 is 2, and 5 divided by 5 is 1. Now, is there any prime numbers that go into these? No. The only thing that goes into those is 1, and that's not prime. So this is it. Now, how do I get the answer? I take all of these numbers, here, 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 and here, and I multiply them all together. So I would have a lowest common multiple of 3 times 2 times 5 times 3 times 2 times 1. 3 times 2 is 6, times 5 is 30, times 3 is 90, times 2 is 180, times 1 is still 180. Our answer is 180. Alright, a word of warning. If I do the same question over again, I'm going to do something wrong. See if you can spot it. I didn't have to divide by 3 here. What's another prime number I could have used? How about 5? 5 goes into 20 and 30. So I'm going to divide by 5. Does 5 go into 18? No, so I just bring the 18 down. 5 goes into 20 4 times, and 5 goes into 30 6 times. Now, 18 and 6, that's good. I could divide them both by 6, right? So 18 by 6 is 3. 6 doesn't go into 4, so I just write that down again. And 6 goes into 6 one time. Okay, anything still we can do here? Actually, no, this is it. So I shouldn't have drawn that last line back there. Can I get rid of it? So what I end up with is 3, 4, and 1. So in order to get this answer, I have to multiply this, 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 and this will give us the answer. So that means the lowest common multiple is 5 times 6 times 3 times 4 times 1. 5 times 6 is 30, times 3 is 90, times 4 is 360. I got a different answer in here. Why? What did I do wrong? Do you see it? Did you notice? Did you start screaming when I made the mistake? This is wrong right here. Why? You have to divide by a prime factor. Okay, so that was not good. This is not the correct answer. This is the correct answer. Alright, GCF and LCM, don't get them mixed up. Remember, greatest common factor, take the smallest exponent. For lowest common multiple, take the greatest exponent. Backwards, but not so difficult to remember. Alright, take care.
Too many shadows, whispering voices, faces on posters, too many choices. If, when, why, what, how much have you got? Have you got it, do you get it? If so, how often? Which do you choose? A hard